The first lesson in Unit 14. Just going to be 3 lessons in this whole unit. This is our introduction to trigonometry. So here's some things that you just need to be told. You could not possibly have figured these things out. They're just definitions. What we call in mathematics the sine of an angle. Now, these 3 letters are an abbreviation for the 4-letter word sine, S-I-N-E. Don't ask me why some mathematician felt compelled to abbreviate a 4-letter word down to a 3-letter word. Whatever, mathematicians are they're notorious for being lazy. Anyway, the sine of an angle. The definition of this expression here, the sine of an angle, means if you place that angle inside of a right triangle, okay, so if it's going to be in a right triangle, then that angle is going to have to be an acute angle, right? So here's a right triangle. Let's call this angle A here. All right. The meaning of this expression, the sine of an angle, is you divide the length of the side opposite from that angle. That's what the O stands for. Opposite from that angle. Well, here's 3 sides in this triangle. Both of these 2 sides are actually making up that angle. These 2 sides are part of that angle. The side which is opposite that angle is the one side which is not actually forming this angle. Okay, we say opposite. We might say across from, but we don't say across from because we don't want to confuse what this letter A stands for, and it does not stand for across from, and I'll get to that in just a moment. So we take the length of the opposite side, however long that is, opposite from that angle, and divide by h, the hypotenuse of the right triangle, which of course is always across from the right angle. Okay? So divide those 2 lengths, you get some value, whatever it is. Obviously the hypotenuse is the longest side in the triangle, so dividing either of the legs by the hypotenuse is going to result in some number less than 1, some decimal value. It could really be anything at all, but it'll definitely be less than 1. Okay? Then we have this expression here, which you've just got to learn and memorize also. This COS is an abbreviation for the word cosine, C-O-S-I-N-E, cosine. This is sine, this is cosine. Okay. By the way, when we read this mathematically, all right, we pronounce it sine of angle A. I know it looks like sin of angle A or sin of A. Don't say sin, not because the word sin is bad or evil or inappropriate. Okay, just you shouldn't say sin because it sounds like you don't know what you're talking about. Nobody who's learned trigonometry says sin. We all say sine, even though it looks like sin. So please get yourself in the habit of saying sine of A. And one other thing, even though there are parentheses around this angle A, there's no multiplication here between the word sine and the measure of angle A. There's no multiplication, right? I mean, if we had something like this, 2 and then in parentheses an x, we understand that that's 2 times x. But this is not sine times angle A. That's simply not the meaning of this expression, okay? It's more like the meaning of this expression can be understood if you've learned anything about functions in algebra, which I expect you probably all did in first-year algebra. When you see this expression, it's not f times x, it's f of x. There's no multiplication there. And we say the word of. We say the word of here, sine of angle A. Just like if we had a square root and something underneath it, there's no multiplication there between the square root symbol, okay, and the number 17. That's not square root times 17. We say square root of 17, okay? So this is sine of angle A, not sin times angle A. Sine of angle A, and this is cosine of angle A. And the meaning of this expression, the cosine of an angle, is, once again, you've got to have a right triangle, and that angle has to be one of the acute angles in that right triangle. And then the value of this expression is found by dividing the side of the triangle, which is, what does that capital A stand for? It stands for adjacent to, A-D-J-A-C-E-N-T. I think you know what that word means. If you park adjacent to somebody in a parking lot with your car or your bicycle, let's say, that means you pull up right next to them. If you're sitting adjacent to somebody in class, you're sitting right alongside them, right next to them. So to find the value of this expression, we take the side in the triangle which is adjacent to the angle. Now, again, here's this example picture here of a triangle, and here's my angle A. All right. If we're talking about the side adjacent to angle A, we're clearly not talking about the side which is opposite from the angle, right? That one over there. It's got to be one of these two. Okay. Now, both of these sides of the triangle are part of the formation of angle A. In a sense, they are both touching angle A at that point, or forming angle A at that point. I mean, how would you say that one of them is next to angle A and the other one is not? How could you distinguish between these two sides? So you have to learn which one of these two sides is the adjacent side and which one is not the adjacent side. And that's a little tricky when you're first looking at it, but I bet some of you could know. Well, the answer is that the one of these two sides, which is the adjacent side, is the one side which is not the hypotenuse. Okay? So that's the hypotenuse, of course, because that's across from the right angle. This must be the side which is adjacent to angle A. Okay? And you divide the length of that side by the length of the hypotenuse. And again, since the hypotenuse is always the largest side of the triangle, this ratio is going to be some decimal value less than 1. Okay? Finally, there is this new expression which you have to commit to memory. It's this TAN is short for the word tangent, T-A-N-G-E-N-T. Now in geometry, this word tangent means something rather different, and we learned about that. A tangent to a circle is a line that just touches the circle at one point, and it doesn't really pass through it at 2 points. And truthfully, there is a connection can be made between the idea of a tangent in geometry and the idea of a tangent in trigonometry, but it takes a lot of work and explanation to make that connection. I'm not going to bother. Just know in trigonometry, the tangent of an angle is defined, it's just a definition here, and one that you have to memorize, as dividing the side which is opposite from that angle by the side in the triangle which is adjacent to that angle. Okay, so again, if here's your angle A, the side which is opposite is this side. The side which is adjacent to angle A, once again, is not the hypotenuse, but this side here. So dividing this side by that side. Since this side is smaller than that side, we would, of course, get some value that's less than 1. But it is possible, let's say we wanted to find the tangent of this angle B over here. Okay. Then we would be dividing the opposite side, which is this long leg over here, by the adjacent side to angle B, which is this short one. We'd be dividing a larger number by a smaller number, and so we could get a value larger than 1. In fact, we could get values extremely large for the tangent of an angle, whereas these two values, sine of an angle and cosine of an angle, will always, always, forever be something less than 1. Larger than 0, but less than 1. Okay? And again, here's this note. These definitions only make sense for acute angles inside of right triangles. Obviously, with the word hypotenuse in the definitions, these definitions couldn't make any sense unless they belonged to right triangles. But this also is a definition for angles, for acute angles in right triangles. And it's got to be the acute angle. We would, in this course, we will never talk about the sine of a 90-degree angle or the cosine of a 90-degree angle. Such a thing is possible to talk about, and you will learn about that perhaps next year in Algebra 2. But in this course, we won't. All right? These definitions become confusing if you start taking this angle here to be a right angle. Why would they get to be confusing? Well, let's see. For cosine of an angle, if we're taking this angle to be the right angle in this picture, then we'd have to divide the side which is adjacent to that right angle. Well, would we be talking about this side or that side? I mean, who's to say? It could be either one. The hypotenuse is very clear. It's still over there. But then would we divide this by the hypotenuse or this by the hypotenuse? It's not clear. It's very ambiguous. So this definition simply does not work for a 90-degree angle. It becomes confusing. Okay? So the tangent definition also becomes confusing because, again, which side would be the adjacent side to the 90-degree angle? Right? Now, I suppose you could make some sense out of the sine of a 90-degree angle, but we're just not going to talk about the sine of a 90, the cosine of a 90, or a tangent of a 90 in this course. Okay? So here's some examples of a couple of right triangles. And there's names for all of the letters or the angles. And so in class, I would just ask you, hey, try to fill in the values of these expressions. So let's go over them quickly here. The sine of angle P. Angle P is up here. Right? The sine of an angle is the opposite side divided by the hypotenuse. Here's the opposite side from P. Okay? Now let me emphasize this again. Opposite is a relative idea. Opposite sort of depends on where you're positioned in the triangle, right? I mean, the 15 is the side that's opposite from P. But which side is opposite from S? Well, that's the 8. Okay, so it doesn't make any sense to ask this question. In this triangle, which side is the opposite side? That makes no sense. Opposite from what, you would have to ask me. Okay, and then if I said, oh, I mean opposite from P, then you would say, well, then the 15. If I said opposite from S, you would say the 8. Okay, so sine is opposite divided by hypotenuse. The opposite's 15, the hypotenuse is 17. There's the value of that expression, the sine of angle P. Cosine of angle P. Cosine is the adjacent divided by the hypotenuse. Go up to angle P. The adjacent, is it the 8 or is it the 17? They're both adjacent to angle P. Yeah, except the 17 is the hypotenuse. And the hypotenuse is never an adjacent side. Okay, so 8 is the adjacent side. 17 is the hypotenuse. So the value of this expression is 8 over 17. And finally, the tangent of angle S. Okay, so now we're going over here. Now we're looking at the triangle from this point of view. And tangent of an angle, and again, you just got to commit this to memory, although since we're doing this remote learning, do you really have to? No, but this is something you're going to need to learn eventually. You're going to have to know this without being able to look it up. Tangent is opposite over adjacent. From angle S's point of view, the opposite is 8. The adjacent is it the 15 or the 17? Well, it's got to be the 15 because 17 is the hypotenuse. So 8 over 15. Before we go through the next set of questions, 4, 5, and 6, I want to draw your attention to this word up here, Sohchatoa. We usually pronounce that SOHCAHTOA, okay? And it's not a definition, it's not a law, it's not a rule, it's not an equation. It's just a memory device. It's a memory aid. We call this memory aid an acronym. Maybe you've heard that word before. An acronym is a word made up of usually the first letters of a bunch of other words. Like the word homes is an acronym that you might have learned to memorize the names of the Great Lakes. Lake Huron, Lake Ontario, Lake Michigan, Lake Erie, Lake Superior, right? So this is an acronym. And students have been learning this word. This is not my invention or even a recent invention. Students have been learning this word for many, many years. Dozens, maybe hundreds, I don't know. But for a long time, students have been using this word to remember. How does this help you remember these definitions? Because the order of the letters reminds you that the sine of an angle is equal to the opposite side divided by the hypotenuse. The cosine of an angle is equal to the adjacent divided by the hypotenuse. And the tangent of an angle is equal to the opposite divided by the adjacent. SOHCAHTOA. Now, this word doesn't do you any good unless you remember how to spell it, okay? And on rare occasions, I've seen students, write it on the margin of their quiz or test as soon as they get it, but they spell it wrong, and then they get all the answers wrong, okay? SOHCAHTOA. Here, I know you're going to feel silly doing this, sitting wherever you're sitting watching this video, but say this out loud after me. Ready? SOHCAHTOA. Say it. One more time. SOHCAHTOA. Okay? If you say it out loud, it'll help you remember it more easily. I promise you. Say it out loud. If you haven't said it, say it now. All right. So, cosine of angle B. All right, cosine, that's the C. SOHCAHTOA. SOHCA. See, when you know that word, SOHCA, you go, cosine is adjacent over hypotenuse. All right. Angle B is over here. The adjacent to angle B, it's either this side or this side, but that one's the hypotenuse. So adjacent has got to be the A, hypotenuse is the C, the value is A over C. Tangent, let's see, SOHCAHTOA. Tangent, the T, SOHCAHTOA. Right? Toa, T-O-A. Tangent is the opposite over the adjacent. So from angle A's point of view, the opposite is A, and the adjacent is either the B or the C, but the C is the hypotenuse, so the adjacent must be the B, A over B. And finally, sine, SOHCAHTOA, S-O-H. Sine must be the opposite over the hypotenuse. All right? The opposite from angle A is the A, and the hypotenuse is the C, so A over C. All right? Okay, let's look at these 4 examples down here. Find sine of angle F from the triangle below. Okay, once again, SOHCAHTOA, right? The S is the beginning letter in that first 3 letters of the word SOHCAHTOA, so opposite over hypotenuse. From angle F's point of view, the opposite is, it wasn't given in this problem. The hypotenuse was, but the opposite side wasn't. But hey, it's a right triangle, okay? And we've got 2 out of the 3 sides in the right triangle, so we can use the Pythagorean theorem to find this missing side and then come up with this value. So here's your Pythagorean theorem work. The opposite side turns out to be 7, and so the sine of angle F is 7 over 25. Once again, the opposite side is 7, the hypotenuse is 25. Okay? Now, here is a problem where I've given a picture of a triangle and called it triangle ABC. And I said, let's suppose, what if the sine of angle B is 5/13? Then find the cosine of angle B. Now, this 5, this 13, and this x were not present in this triangle in the original problem. Okay? I put those values in there on the basis of this given information. Okay? And this is something you have to learn how to do. It's telling me that the sine of angle B is 5/13. Now, I know that the sine of angle B, the sine of an angle, is the opposite side over the adjacent side. Again, from the word SOHCAHTOA, right? So, if the sine of angle B is the opposite over the hypotenuse, and that's 5/13, then from angle B's point of view, I'm going to go to the opposite side and write a 5, and I'm going to go to the hypotenuse and write a 13. Okay? That information came from me reading this information and transferring that information properly into the picture. And that's something, again, that you have to learn how to do. Okay? Once I put that information in, and I want to find the cosine of angle B, SOHCAHTOA, C-A-H. The cosine is the adjacent over the hypotenuse. Okay, that's why I wrote that down. So I'm going to need, from angle B's point of view, the hypotenuse, which I know is 13 from that information, and the adjacent, which, well, I don't know the adjacent. But again, now that I know 2 out of 3 sides in the right triangle, I can do some Pythagorean theorem work to find that missing side, which turns out to be 12, and then I can finish writing the answer to this question. The cosine of angle B is the adjacent 12 over the hypotenuse 13. Okay? When you get to the test in this unit, you get a problem like this, I expect to see this work, this Pythagorean theorem work. If you need to do it, you better write it down for me. You get a problem like this, and you don't write anything in the picture, and you just write the correct answer, I'm not giving you any credit, okay? I expect to see you put these numbers in the picture where they belong. I expect to see the Pythagorean theorem work, and then give me the answer, and you'll get the credit for the problem, okay? Same with this problem over here. I expect to see the Pythagorean theorem work, all right? Find tangent of angle Q. There's really nothing different about this problem from the previous two, or let's say from this problem up here. I gave you 2 out of the 3 sides, but to find the tangent value, and again, going back to the word SOHCAHTOA, tangent is opposite over adjacent. From Q's point of view, I don't have the opposite. I do have the adjacent, but I don't have the opposite. So Pythagorean theorem gets me the opposite side. This turns out to be not a nice whole number. Square root of 65. Okay, so what? So the tangent value turns out to be square root of 65 over 4. Leave it like that, okay? Square root of 65 is not a nice number. Do not turn this into a decimal, and do not round this. Oh, and by the way, don't waste your time turning these fractions into decimals. Absolutely, positively do not, because it is a waste of time. Okay? Fractional answers are perfectly fine with me, and my answers on my answer key are going to be fractions. And so if you're writing decimals, now I got to stop and calculate my fractional answer as a decimal to see if it matches yours, and now I'm wasting my time also, okay? But I don't want you to waste your time. Leave the answers as fractions, okay? Now, here is the most involved problem on this whole page. All right? No picture was given for this. This problem is kind of like number 8. I mean, look at how it starts. If sine of b is this value, if cosine of e is that value. And then the problem says, find the cosine of that same angle. And this finishes, find the sine of that same angle. Very similar problems, but this time I gave no picture at all. So you're going to have to learn again, and there will be problems like this in the homework assignment going along with this. So if you do the problems, you'll learn this, and it's not difficult. you got to draw yourself a right triangle picture, and it must be a right triangle. Again, talked about that earlier on. So draw a triangle, put a right angle in it. All right, but now, where does angle E go? I put it over here. Does it have to go over there? Could it go at one of the other angles in this triangle? What do you think? Well, it can't go at the right angle. Again, because I've said we are never in this course going to talk about the sine, cosine, or tangent of right angles. So E cannot be the right angle. Could it have been this angle? Could I have put the E over here? Well, the answer is yes, I could have. Okay, it's just got to be one of the acute angles. It doesn't matter which acute angle you make it. So just pick one. Okay. So I picked this one. Then I was able to properly put this information in my diagram. Let's see, cosine, what is it? SOHCAHTOA, SOHCAH. Cosine is adjacent over hypotenuse. So square root 3 must be the adjacent side to angle E, which is this one here. 2 must be the hypotenuse, which is there. Okay. And now to find the sine of angle E, I need the opposite side, which again I don't know, but again I can find again using the Pythagorean theorem. X turns out to be this nice whole number 1 this time. And so the sine of the angle, which is the opposite over the hypotenuse, is 1 over 2. Leave it as a fraction. Okay, 1 over 2. So that's this lesson. I don't think you're going to see really anything in the homework that is any different from any of what we've just gone over here. I just want to take a quick peek while you're looking at my notes. Is there anything in here? Well, let's see. Actually, yeah, when you get to page 2, so I want to give you a sneak preview of this. Or maybe it's page 3. Actually, it's page 3. Pages 1 and 2, very, very straightforward stuff. Going to be exactly what we just did. Now, page 3, I have a diagram here of just a random 30, 60, 90 triangle. I have not given specific values for the sides of the triangle, but we know whatever the short leg is, and I'm calling it X, the hypotenuse is going to be twice as much as the short leg. So I'm calling it 2x. And the long leg is going to be the short leg times the square root of 3. Okay? This is for absolutely any 30, 60, 90 right triangle, right? We learned this quite some time ago. I'm sure this is familiar to you. So I want you to use this triangle to come up with values for the sine of 60 degrees and all these other expressions here. Now, I want you to be aware that when you first write the values of all of these expressions, there's going to be x's in your answers. But I'm pretty sure in every single one of these answers, the x's, you're going to have an x in the numerator and an x in the denominator, right? Because every one of these definitions means you're dividing one side by another side. And every one of these sides has an x in it. So you're going to have an x in the numerator and an x in the denominator. And what should happen if you've got an x in the numerator and the denominator? The x's should cancel out, right? And you'll end up with just numeric values for all of these expressions. Okay? So just be aware of that. And then here's a picture of a 45, 45, 90 right triangle. Okay? And I want you to try to remember what we should call this side of the triangle here if I choose to call this side x. And what would we call the hypotenuse of this triangle? How is the hypotenuse's length related to the length of a leg in a 45, 45, 90? Do you remember? If not, it'd probably only take you a minute to look that up in some old notes or something. Let's see, I'll give you a hint. I believe it's unit 9. Is it unit 9 that we did 30, 60, 90 work? Well, it was 9 or 10. Okay, if you need to look that up. So there's a some hints about the homework, and I think you should be fine. Work through these problems. Really, really work through this handout before you go on to watch the next video. You want to get like an almost like reflexive understanding of these three definitions here, where like when I say sine of an angle, you just like reflexively, you know, oh, it's opposite over hypotenuse. Like you don't even have to think about it. And working through the assignment will build that kind of reflexive or instant memory recall for you, and then you'll be in much, much better shape to watch the next video and do the next assignment. Okay?